Zeros of polynomials. All right. So there's some words that are going to be used interchangeably because they all refer more or less to the same concept. Those words are zeros, which mean the same thing as an x-intercept, which are going to mean the same thing as roots. So a root of a polynomial, a zero of a polynomial, and an x-intercept of a polynomial all refer to the same idea. It's where the function is equal to zero. I.e., y equals zero. When we say that the function equals zero, we mean that y equals zero. There's a really important theorem, and it says this. It says if x equals c is a zero of a polynomial, then, and this goes in both directions, x minus c is a factor of the polynomial. If you're wondering to yourself, what does it mean to be a factor of a polynomial? If you write something like x plus 5 times 2x minus 7 times x plus 8, this right here is a factored polynomial because if you were to multiply it out, it would be a polynomial. It would follow all the rules of being a polynomial. Each of these pieces that are multiplied together is a factor of the polynomial. X plus 5 is a factor of this polynomial. 2x minus 7 is a factor of this polynomial. So that's what it means to be a factor. If we say that x equal to 7 is a 0, then x minus 7 is a factor of the polynomial. So I'm just going to put down a few examples here. I just did 7 out loud, so I'll say it again. If 7 is a 0, that means that x minus 7 is a factor of the polynomial. If negative 9 is a 0, then x minus negative 9, which simplifies to x plus 9, is a factor. I'm not going to write of the polynomial again. That's too much effort. If 0 is a 0, and I understand that sounds funny, but if 0 is a 0, if there's an x-intercept at 0, that means that x minus 0, which would simplify to just x, is a factor. What would it look like for x to be a factor? Well, nope. Just kidding. This thing is going to give me issues there. What if I do this? It'd be like there is an x out front. That would make x into a factor. Notice on this that whatever the 0 is, when you see it in its factor, it's the opposite sign. So if 7 is a 0, x minus 7 is a factor. If negative 9 is a 0, x plus 9 is a factor. All right, I meant to take away this degree part. We just don't need to talk about it right now. It thought I had erased that. So find a polynomial whose real zeros and degree are given. again, I just took out the degree part because that doesn't matter. Here are the zeros that we're given, and we want to find a polynomial who has those zeros. It's not bad at all, promise. So if you have -2 as a zero, its factor is x plus 2. Again, that's because we would be doing x minus -2, and that would simplify to a plus. And then we have -1. If -1 is a zero, x plus 1 is a factor. If 1 is a zero, then x minus 1 is a factor. And if 5 is a zero, x minus 5 is a zero. So how do we put together a polynomial that has all of these zeros? We just take all these factors and multiply them together, and that's it. F of x equals x plus 2 times x plus 1 times x minus 1 times x minus 5. And that would be our answer. You could, of course, put any number you want in front of this polynomial, and it wouldn't change what the factors are. I could put a 7 out here, and it would still have these factors. Now, if you put an x out front, that would make 0 into a 0. So we wouldn't want to do that. But anyway, in general, it's just x minus the 0 makes a factor of the polynomial. In other videos, we're going to talk about this idea called multiplicity and how that affects our zeros, because our zeros have this property that is their multiplicity that does fun things to them. But from this video, what you need to understand, first of all, that zeros, x-intercepts, and roots are all the same idea. They're all where the function is equal to 0. And then this really important theorem that I cannot emphasize enough is incredibly important. All right, and I think, yep, that's all we have for here. I will see you in the next video. Bye.